Hey there, we are working on chain rule examples. So the first chain rule I have is we have two functions. The outside part of the function is the x cubed. The inside part of the function is this 3x squared plus 1. We are finding the derivative of this. So the first thing we want to do, think of the y as being your outside function, and then this u here as being your inside function. So we want to find the derivative of the outside. So derivative of this is 3u squared. Derivative of this is 6x. Remember that plus 1, that's a 0, so we don't have to do anything else with that. Then you want to substitute u back in. So I still have a u here. Everything needs to be in terms of x, so I need to substitute that back in and then simplify everything down. And I probably would stop right here. Actually, I would probably stop. This was the book's notes. I would write it like this. Make it nice and simple and easy. Why go through all this spot? If you want to, you can simplify. It's going to be really easy to substitute in for an x value there. So I'm going to stop there. All right. Next thing we have is we are finding the derivatives here. So my outside is the squared. The inside is x squared minus 3x. So I am finding the derivative of the outside. Inside remains the same, and I'm multiplying it by the derivative of the inside. So the inside is 2x minus 3. Simplify everything down that we can. What do we got? I'm going to multiply the 2 by this. I'm going to do this one first. So I got 4x minus 6. And this is just to the first, so I can multiply through here if I want. So what I got, 4x cubed. So 4x cubed minus 18x squared minus 18x. Second one, down here, we have dy dx. Outside is your cosine, so I do derivative of cosine, which is sine. Inside remains the same. Then I multiply it by the derivative of the inside, which is 2x. I like to, again, put that 2x in front so I don't confuse this as a multiplication because it's not. And there is my final answer. Next page, again, we are doing the same kind of stuff here. Object moves along the x-axis. I'm pretty sure you've seen plenty of these by now. So that its position at any time, t greater than or equal to 0, is given by this function. Notice that there's an outside function and an inside function. We're finding the velocity of the object as a function of t. So we're just finding the velocity equation on this. So as I do this, I do the derivative of the outside. My inside remains the same. Then I multiply by the derivative of the inside. And I'm going to simplify. Again, I'm putting this guy in the front so I don't confuse that with a multiplication. There it is. I think we have time for one more before the bell rings and people come flying into my classroom. So find the slope of the line tangent to the curve of this at the point where x is pi over 3. So we need to, again, in order to find the tangent line and we're looking for slope, we're looking for the derivative. So dy dx is derivative of the outside. So if you think about it, this is really what that means. So outside function is that power to the x power. So inside remains the same. I just did the derivative of the outside. It's a power rule. So I just took the exponent, moved it down, subtracted 1 from the exponent. Then I multiply by the derivative of the inside. There is nothing to simplify here, but I am evaluating at pi over 3. And we are doing 5. What do we get? Up there, square root of 3 over 2 to the 4th. Cosine is 1/2. To the 4th is 16 and 1/2. So I get 45 over 32. And, well, maybe we can do another one. I was pretty close, pretty fast. So on this one, it says, show the slope of every line tangent to the curve here that it's positive. So I'm just going to find the slope. So I can write it, I can write it like this, or I'm actually going to, now that we know chain rule, I'm going to write it like this. So I don't need to use that quotient rule formula, because who really wants to use that quotient rule formula when you can do power rule with the chain rule? So I am doing the outside function, the derivative of the outside function. I brought the exponent down, subtracted 1. Inside remained the same. Then I multiply by the derivative of the inside. So I got 6, 1 minus 2x to the fourth. Negative fourth. If I rewrite this, I'm showing that this is positive. Well, it doesn't matter what value of x we have, because we're taking it to the fourth power. This will always be positive. And that is it for this section. Thanks for playing.